What I've also noticed in your tutorials is that you put a lot of focus on the more low-level stuff. I think you are building your own programming language, and I think you also worked on a compiler. Is that right?
Yes, that's correct. Yep.
And what's your motivation for that?
Um, so there's a number of reasons. So the first thing is that I'm a nerd. I want to understand things that I'm interested in at a very deep level. And one of the things that will happen to you, especially if you're a self-taught developer and you're starting in a high-level language like JavaScript or Java or any JVM language really, is that you might be really good at building applications, which is, a very profitable skill and nothing to laugh at. But you're probably not going to understand things at a lower level. And this was a huge contributor of kind of like an imposter syndrome for me doing my videos. I hated it that I didn't understand these lower level concepts. And then it was also just, I would meet people who had degrees who couldn't build an application to save their life. Like the worst I ever met. Nice fellow, but he had a master's in computer science and he didn't have a GitHub account or any kind of revision control. He'd never written any executable code and deployed it to a platform or deployed it to revision control or anything like that. And he was actually wondering why he couldn't get work. So, so meeting those people, I thought to myself, well, the one thing they really have over me, assuming they paid attention in classes, is this knowledge of these lower level concepts. And then finally, I thought to myself, there's probably things here that would make me a much better app developer. Like a great example would be the concepts in software engineering, which is a topic that I avoided like the plague for like my first 4, maybe even 6 years as a software developer. Because I thought it was very math heavy and stuff like that, and I just hated math. I was good at some kinds of math like calculus, but arithmetic I still suck at. So it was a number of different things, wanting to understand these things, wanting to be a better teacher. And then I think what really kind of clicked is that the first time I really dove into one of these topics was software architecture. And a funny thing happened, which has been happening my entire career as a programmer, which is that when I finally got over my fear of the topic and put the time in and sifted through a bunch of really awful resources, because that's what scares a lot of people away from these topics, is there's just not very many good teachers. There's more good teachers for software engineering now, but some of the lower level topics like digital circuits and stuff, there's still not a lot of good resources. Once I got over that fear and actually got into these things, I was able to realize that in many cases, they were a lot easier to understand than I thought. For some people who are listening, this might be a little bit useful. It might be useful for me to share some of the things I did to learn these topics. Let's take digital circuits, for example. I'm not going to go into technical details about metal oxide or the metal oxide semiconductor field effect transistors. I'm not going to talk about that crap. What I did to learn how digital circuits work, which is basically how a computer works at the lowest level, we're not even talking really programming language, or zeros and ones. Zeros and ones is an abstraction on top of digital circuits. What I did to learn this is I built a computer in Minecraft. It took 3 weeks to do it. But in doing that, I now feel absolutely comfortable with my understanding of how a computer works at a low level. And I did take an MIT course and I forget most of it and I didn't understand any of it because it was just jargon. But now I actually understand how computers work at a low level in a way that's very easy for me to think in sort of 3D. A level up from that, someone might want to look into operating systems. So what I suggest, and shout out to my friend Jamie Corkill for suggesting this book to me, Operating Systems, 3 Easy Pieces, is a great way to learn how computers work at the operating system level. It's a free book that you can find. Now, with that being said, if you're a beginner, don't do that. It's after a couple of years, if you're comfortable in Java, quite good with it, you might want to look into that. If you're an absolute beginner, it's it's pretty technical C code, but it just does a good job of explaining how these sorts of things, like how does a CPU work, how does virtual memory work, that kind of stuff. My current learning project is compiler development. So for those people who don't really understand what a compiler is, in very simple terms, it is a program. It's a program that you feed source code into. So for example, it could be a Kotlin code. You feed it into the Kotlin compiler, that thing will translate that code. It'll translate it into some intermediate language, usually what they call IR, intermediate representation. But it'll translate it into like JVM bytecode, or it'll translate it into machine code if it's targeting native or whatever. So basically what I thought is I wanted to learn how we get from like Java to executable code. I wanted to learn how that compiler process works because it was just a personal goal of mine. So the first thing I thought to myself is I'm going to do what I always do, which is I'm going to build a project that I can run that is a compiler. So, and then in learning about compiler development, you could write a compiler for a different language and it can work. I could write my own Kotlin compiler. But then I thought to myself, why don't I try creating my own language as well? So that was on a certain level kind of a mistake because that took a lot longer to sort of do, like to actually design a language. It's a very simple language. It's called Donk, which is short for donkey. Big surprise. So I have the basic sort of specification for the language set up. It actually looks quite a bit like Kotlin. Not sure why. Might be my favorite programming language. And then I have the sort of the first two stages of the whole compilation process done, which is like a tokenizer, also known as a scanner, also known as a lexer, people with their stupid jargon words. And then I have a parser built. I kind of just completed that. And then I need to write the compiler thing, which will take that crap and then make it into something that can be run on, say, WebAssembly. So yeah, that's my current sort of learning goal. And probably after I sort of figure out compiler development, then I'll probably get into machine learning.
Yeah, it's interesting that you say that ones and zeros are already an abstraction, because I've always thought the same. When I hear people talk about abstraction, they usually say the computer only understands zeros and ones, but that's not quite correct. Zeros and ones are already an abstraction. So what the computer understands is basically on and off, or is it correct? Electricity or no electricity?
That is exactly right. And I really didn't understand what bits were until I built this computer in Minecraft and realized that, let's say we're talking about a 64-bit computer. I want you to imagine, hopefully someone has played Minecraft when I explain this. Imagine you have like redstone lines, 64 lined up in a row. And then if one is on, so has the electrical charge, then that would indicate the abstraction of that is a binary digit, like a 1 or a 0. So you're exactly right. 0 and 1 is a mathematical abstraction over top of wires that are on or off. It doesn't have to be wires, but for the purposes of modern computers, it's probably going to be a tiny little wire.
Yeah, Minecraft sounds like a fun way to learn the basics of this. I've seen on YouTube some people building these redstone computers, and it seems like a nice way to have, or a fun way to learn this stuff.
Yeah,
so maybe I should try this as well.
I do suggest it. The tutorial I watched was by this YouTuber named, I think, Redstone Without Limits. Some parts of his tutorial was hard to follow because he would make a few off-camera changes. But about 3 weeks of strong effort is what it took me, and by the end of it, it was totally worth it. It was really cool to be like, hey, I literally built a computer.
Yeah, this would actually be a nice idea for a live stream. Have you considered that? Just playing Minecraft for a few hours or days and building something like that?
I have wanted to do tutorials on it for sure. Yeah, it's on my list.
Yeah, I would definitely watch that. And going more into this low level topics would definitely also benefit me, because I don't have enough knowledge there. But the problem for me, I have two problems with this. First of all, I would probably find it too boring. I already have problems getting through the clean code book from Bob, Uncle Bob. Bob Martin is his name, right? Or Robert Martin.
Yep. Uncle Bob.
Robert Martin. It's already difficult for me to get through this book. And the other problem is that doesn't it make it difficult to keep up with the changes in the higher level topics, because the programming landscape is changing fast, and I feel like I'm already completely I already need all my time to just keep up with this. So learning these lower level topics, it feels like I don't have the time for this. I don't really have a question for you regarding this, but this is just my problems and the reasons why I don't do this at the moment. Or do you have anything to say about this?
Yeah, I think that's very true. And one of the things people who follow my channel probably have noticed is that I've stopped using a lot of new Android libraries. I will only use, and it's not just Android, nowadays I will only use a library if I believe it solves more problems for me than it creates. And a big reason for that was because I've been spending a lot more time learning these low-level topics. So a great example would be like Kotlin flows. I'm perfectly comfortable building asynchronous Android applications without using Kotlin flow. So it's not something that, it's definitely something I would learn given the time, but I wasn't a big fan of RxJava, so it's not like I want to recreate that in Kotlin to begin with. But that would be an example of something that I literally haven't learned that because I don't feel like I have the time to do it. So I think that's absolutely true. And I think the one thing I would say for anyone listening, who a good topic that most people avoid and I avoided because it was boring and not presented in a way which was useful, would be software engineering. I'm not going to give a big, huge lesson on software engineering, of course, but the one thing I would say to people is, if you want to make software engineering relevant and interesting to you, you have to understand when it becomes relevant. The truth is that for many, many applications, like especially smaller applications and demo applications, you can have zero knowledge of formal software engineering and build great applications. Where software engineering gets really important is when the size of your user base, for example, is enormous, the size of data sets are enormous, or when the time it takes to do some operation in your code gets really large potentially. That's what software engineering is all about, is how do I rewrite this code where it takes less time to execute, or it's more efficient with respect to memory. But those sorts of things aren't relevant for many, I would say the majority of applications which people write. But if anyone was wondering, why does Google, why does Amazon, why do Facebook give you these insane, like they just fire a barrage of these questions at you, is that they're dealing with data sets of like millions and potentially billions of items. So in that situation, software engineering is incredibly important, and it can mean the difference between a completely useless application and an efficient application. So hopefully for people listening, that might be an interesting little thing about why they barrage you with these questions. And also, if you think of building an application that has potentially a big user base, that can be an area where you can start to maybe focus your approach and learning in.
So you recommend to people who want to work at companies basically to definitely learn also the slower level stuff?
Software engineering in particular. I mean, I'm not sure how much they're going to quiz you on computer science concepts specifically, but definitely I've applied to several of the big companies. I actually did well in a Facebook interview just as COVID was happening, and then they denied me. I didn't get the third interview because they didn't want to sponsor me for a visa. So I was really pissed about that. But anyways, yeah. If you're going to be applying to one of these large companies, they're going to give you all kinds of questions about software engineering, data structures and algorithms, and what's called big O complexity. And so if you're going to apply to those places, you really want to understand those core concepts.
Yeah, this is probably, this is one of the reasons why I didn't really need to learn this yet, because I'm not planning at the moment to apply to any of these companies. So maybe I can get away with ignoring some of the lower level stuff, but it would definitely be interesting. And yeah, you already mentioned that you don't use most Jetpack libraries. This was also something I noted down, which I have noticed from your videos. You don't use most Jetpack libraries, right? You build the stuff yourself. Also, for example, you don't use Jetpack view models. You build your own view models.
Yeah, that's there's some specific reasons for that. So part of it is that so all code changes over time, of course. So you've got, for example, a language which will change over time. You've got maybe like the standard library for that language, so kstdlib or jstdlib, which will also slowly change over time. Then you've got a platform which will change over time. And then you've got like sort of platform libraries / third-party libraries, which will change over time. So all of these things generally, in the order I listed them, will change slower. So obviously third-party libraries and stuff like Jetpack, these things change all the time, very frequently. Like some of them are obsolete a year or two after they're made. So by using less of those libraries, my code becomes more resistant to change over time. And that's been nicer as a content creator, because then I can have something which isn't obsolete in 6 months or whatever. And that's been really frustrating, especially initially. So that's part of it. The other thing is that I am very much an advocate of testing and test-driven development, with the exception that my opinion is that most classes, well, I don't think it's even really my opinion, this is almost just a fact, classes which are tightly coupled to frameworks and platforms, so here I'm thinking of like a view, like a fragment or an activity, by way of their tight coupling, and if you're wondering what I mean by tight coupling, anyone watching this, look at the import statements in a class, and that will tell you what something's coupled to. Tight coupling necessarily makes something more difficult to test. A pure Java or a pure Kotlin class is easy to test. You don't even really need something like JUnit. You could write a main function, give it some data, and then write some little class to see what its output is. I don't necessarily suggest you do that. I do use JUnit, but I don't even use a mocking library these days. So by not using, by keeping frameworks and platforms as isolated as possible, it also makes the other classes potentially reusable across multiple platforms. And secondly, it makes them a lot easier to test, generally speaking. In the case of view model, I should say, Android view model is basically a Jetpack view model that has a reference to context. In the case of view model or Android view model, those libraries don't really solve as many problems as they create for me. It means I need to create them. Hopefully this hasn't changed since last time I looked, but it means I need to use like view model providers to create them. So their instantiation is no longer directly controlled. I'm pretty sure you can hook it up with like Hilt or something, but I can't directly instantiate them myself in my own dependency injection code. And the other thing is that, for example, like live data with Compose now, I'm actually pretty comfortable just writing my own observer pattern, my own observables essentially, or just having like a Kotlin function type that my view binds to. It gives it a lambda, which gives me the same effect as like a live data. So really my lens with which I view every library these days is, can I write it myself simpler, and does that create more benefits? Or is it something where if I tried to write it myself, then it's going to either be a gigantic time vampire on something I'm not really interested in learning? So a great example, am I going to be writing my own view library? Am I going to write my own compose or my own view system with XML? Hell no. I hate UI programming because I know how annoying and mathematical and technical it is. So I have zero interest in doing that. Am I going to write my own version of like retrofit? Probably. So it depends on a lot of different factors, learning goals, longevity, ease of testing. So that's kind of where my current approach is coming from.
Yeah, I'm always a bit scared of writing this stuff myself because there is quite a lot of stuff happening in the source code of these libraries, and there are a lot of details that I would be afraid of missing. For example, I wouldn't be sure if I handled the activity lifecycle properly. So what's your experience with that?
Oh, handling activity lifecycle.
I mean,
So
in general, taking all these small details into account that these Jetpack libraries are, I mean, those are often written by multiple people over long periods of time. So I would be afraid that I'm missing a lot of details when I try to write this myself.
yeah, it's tricky, and if you make the decision, I feel like maybe I'm wrong in this, but if you make the decision to go pretty lean on third-party libraries, you are going to have to own up to the fact that your presenter or your view model or whatever is going to have to be made aware somehow of lifecycle events like OnStart. Like just a typical example in my current approach to architecture, the whether I'm using a fragment or an activity as like a view container, in the OnStart lifecycle or override function, lifecycle function, I will send an event. I basically represent UI events using a sealed class in Kotlin typically. I will send an OnStart event immediately to my presenter. So I have to have my own ways of hooking into those sorts of life cycles. And one of the things you don't get using my approach, especially out of the box, is you have to be careful about how you're dealing with orientation changes or just situations where you're recreating the activity. You have to handle that stuff yourself. And that's a great example of something where a lot of the Jetpack libraries are really quite good at handling those things out of the box. So that's definitely an important consideration.
Yeah, but it's a useful skill to write this stuff yourself because these Jetpack libraries often have bugs and then you have to find a way to work around them, but you can't get into the source code. Has been a problem, for example, in the course I made. In this one paid course I made, that there were certain bugs that I couldn't really solve because those were alpha libraries, but people don't want to see the old stuff anymore, so I have to use these alpha libraries. But yeah, if you can write the stuff yourself, then you have more control over what exactly is happening.
Yeah, there was actually a specific moment where I got really sick of it, is actually with the early navigation library on Android. It might work great now. The early version I used, I ran into situations where the best way to use that library was to just not even use it. Like a great example was in a login feature. The way in my 2019 Android tutorial, the way I was able to build that app, the only way with that login feature was to literally just not use the library in the activity which had the login feature in it due to on-activity result. I don't know if they handle it better now, but when that happened, I thought to myself, like, I understand that this might work well in 80% of scenarios, but it irritates me that this thing just breaks my application if I try and use it. And the funny thing is, like, some people had these workarounds like this, sharing view models and stuff like that. And if it works, it works. But the workarounds were like worse than just not using it. So that was a real big shift.
Yeah, I think that's a common sentiment with Jetpack libraries.